Hello everybody, it's Coach Ronzo here. In this video, we'll focus on how to properly name an angle and where they're located. Now, initially when you name an angle, you can decide, you can go ahead and pick 3 points, but they have to be in a particular order in order for it to be named. So I'm going to use this little person right here that's walking the edge, and they're going to go ahead and walk us through how to name these. So if we're naming that A, is you're starting, and then that person keeps walking, and then it hits this next point, which is B. So it'll be A, B, and then you go to the next point, and then that person just literally just cross over. So if you can walk the line, then it will help out to identify where the angle's at. Now, let's say we had another person. This person's standing at C, or at C, and they walk towards B. So you can name it C, B, and then get on that corner and then walk towards where A is. That's going to be A. So you have 2 names for this, angle ABC and angle CBA. So this little part right here looks like a little alligator. That's what we would call an angle. So angle ABC, angle CBA. Now the other parts you can name this by is by the number 2. So we can call it angle 2. Well, whatever number, it could be angle 12, it could be angle 120, but as long as you can go ahead and just find that value that's particularly in that corner. Now the last one is going to go ahead and be angle B. Now sometimes you'll be given, I know I said 3 points earlier, but sometimes you won't have these points present. And so sometimes if it's by itself, we can call it angle B as a way to name it. Now, the way it's located, so angle B is right here. Anything else? So initially, whatever's in the center of both angles, of both the points. So let's see. I'm trying to get rid of that. Get rid of that. Okay. So what creates an angle? So initially, what you have here is that you have a vertex with 2 rays. So a vertex is initially being shared between two lines. Now, in this case, it happened to be 2 rays. So a vertex with 2 rays. Now, initially from here, we have to go ahead and understand where it's created. So some of you may see an arc, and it kind of makes like a bridge. And this kind of bridge is considered the angle itself. So when you see all these little markings, it initially represents angles. So it can be like 110 degrees, and you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 110 degrees will be there. I don't have the time for that, but to make all the lines. But that's one thing that we have to understand, and that this is actually the angle that's created. Okay, so kind of like a door. So if you see a door, so from bird's eye view, and it kind of just opens in a certain direction, then that would be considered the angle. So where a swivel is down here when it's opening and closing in general. Okay, so it gives you an idea what an angle is named and what's created by. Now the other part is that you have intersecting and then you have bisect. Well, I'm not intersecting. You have interior and then you have bisect. Now, the differences between these two is that when you have an angle that's on the interior, I'm going to create this. I'm just making it up. So we'll call it X, Y, and then Z. And then we'll use the same type, and we're going to see a difference. So for interior, we're creating that angle. So I'm going to go ahead and do dots. Dot, 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 dot. Interior means that any one of these points can be inside the interior of the angle. So if we have a point here, then let's say I walk and then you stop there. that's considered on the interior. So it's necessarily you can pick whatever you want in terms of which one of these you want to go and intercept. So I'm gonna call that angle, well, no, point A, and it intersects point A. So now let's say, so in this case, we'll say point A is in the interior of angle X, Y, Z. Now for the next one, what makes it different is that we're going to use the same ones, X, Y, and Z. And still have the same, we'll have the same points that we can go ahead and use. Now we're going to pick one of these points to say that point B, point A is in the is bisecting X, Y, and Z. So if I go here and I stop, bisecting means it's cutting it in half. So we're going to go to a little halfway point. Now I'm calling that A now. That's my new A. And this is cutting it. So this is bisect. And you have to draw your pictures the way that your angles that in this way to help you solve and visually see what's going on. Now, if you saw this one and that are not the same. They're not the same openings, not the same bridge length. Now, if we focus on this one, our angle necessarily is this bridge that's created. And it's this bridge on this side, it's also created. So it's kind of like where there's the same length in terms of the bridge that's, bridge in this case will be the angle. So it'll be the same. It'll be the same. So in other words, it will be equal to each other. So equal. So that one and that one are equal to each other. Whereas this yellow and the blue one are not the same. Okay? The bridge length is different, so they can't be considered called equal. Now, the other part is that what's the difference between obtuse, right, and straight angle? So when we create an angle, we have to see it as, oh, I have an obtuse, I have a right, I have a straight, and the last one I'm missing is going to be acute. So obtuse, initially what obtuse is when you have, PC, is when you have a set of points and they go ahead and create an angle that's bigger than 90. So my bridge length here would go ahead and be 90, but X would be any sort of number. So it'll be a number that's greater than 90. Now for right, I have literally a perfect L, just like just like with your hands. Now we have L, and so that means it's 90 degrees right here. So that's going to be equal. So remember, when you see the box, that represents 90 degrees for any sets of angles. Okay, so A, I got B, and I got C. Now straight. And this is what straight is when you have a straight line. We have A, we have B, and we have C, and that's going to equal to 180. Acute, pretty much what it is, like acute, so kind of like a small angle. So when I create it, I got A, I got B, I got C, it's pretty much an angle that's less than 90 degrees. So it has to be a degree smaller than that, okay? Little dots to represent degrees. Now, next part is draw a bisected angle. So if we're trying to draw a bisected angle for any one of these, what I would do, or I would recommend, is that once you have one, you want to go ahead and find, imagine like it's like pizza, where you want to go ahead and share with your brother, then you can go ahead and cut it in half. So obviously you can try and make it like seem like, oh, it kind of looks like, if I go ahead and try and cut this where it's going to be even for both of us, I would go point maybe somewhere right there. So I got A, B, C, and this point that's in the interior, or it's in the interior of this angle, is bisecting it. So I'm going to call that point X. So point X is bisects angle ABC in this case. So initially, that's what we have to work on. Just make sure you go ahead and identify what type of angle you're working with, what's the proper name of it, and where's the interior and the exterior.